National Electrical Code Section 701.1 states that the wiring method used for emergency circuits shall be designed and installed to minimize the possibility of damage by fire. National Electrical Code Section 702.5 states that emergency circuits shall be installed in a manner to minimize the possibility of simultaneous damage from an occurrence at any one location. The National Electrical Code requires that emergency circuits be protected from damage in the event of a fire. Connecting a load in a separate building to an emergency panel in a different building increases the risk of all circuits being lost if there is a fire in either building. This would defeat the purpose of the emergency power system. Therefore, each building should have its own dedicated emergency panel and backup generator to ensure that critical loads are powered in the event of an emergency. Let's delve deeper into why this configuration is not compliant with the National Electrical Code and explore the underlying principles that govern emergency power systems. Firstly, consider the fundamental purpose of an emergency power system. It is designed to provide a reliable source of electricity to critical loads during a power outage, ensuring the continued operation of essential services and equipment. These critical loads may include lighting, fire pumps, life safety systems, and other equipment necessary to protect human life and property. The National Electrical Code recognizes the importance of these systems and establishes stringent requirements for their design, installation, and maintenance. The primary concern with connecting loads in separate buildings to a single emergency panel is the increased risk of fire damage. If a fire were to occur in one of the buildings, it could potentially damage the wiring and equipment associated with the emergency circuits, causing a complete loss of power to all connected loads. This would render the emergency power system ineffective and could have catastrophic consequences. The National Electrical Code addresses this concern in Section 701.1, which mandates that the wiring method used for emergency circuits be designed and installed to minimize the possibility of damage by fire. This requirement encompasses a variety of factors, including the selection of appropriate wiring materials, the installation of fire-resistant enclosures, and the implementation of proper fire-stopping techniques. Secondly, the National Electrical Code also recognizes the importance of minimizing the possibility of simultaneous damage to emergency circuits from an occurrence at any one location. This principle is articulated in Section 702.5, which states that emergency circuits shall be installed in a manner to minimize the possibility of simultaneous damage from an occurrence at any one location. This requirement is intended to prevent a single event, such as a fire, flood, or earthquake, from disabling the entire emergency power system. Connecting loads in separate buildings to a single emergency panel creates a single point of failure that could compromise the entire system. If a fire or other event were to occur in one of the buildings, it could potentially disable the emergency circuits serving both buildings, leaving both buildings without emergency power. To mitigate these risks, the National Electrical Code recommends that each building have its own dedicated emergency panel and backup generator. This approach ensures that each building has a reliable source of emergency power that is independent of the other building. If a fire or other event were to occur in one building, it would not affect the emergency power system in the other building. In addition to the fire safety concerns, there are also practical considerations that support the use of separate emergency panels and generators for each building. These considerations include the following. Firstly, load diversity. Each building may have different emergency power requirements. By having separate emergency panels and generators, it is possible to tailor the system to the specific needs of each building. Secondly, maintenance. Maintaining a single emergency power system serving multiple buildings can be challenging. By having separate systems, it is easier to schedule and perform maintenance without disrupting the operations of both buildings. Thirdly, redundancy. Having separate emergency power systems provides redundancy, which increases the overall reliability of the emergency power system. If one system fails, the other system can continue to provide emergency power. In summary, connecting loads in separate buildings to a single emergency panel is not compliant with the National Electrical Code because it increases the risk of fire damage and compromises the reliability of the emergency power system. The National Electrical Code recommends that each building have its own dedicated emergency panel and backup generator to ensure that critical loads are powered in the event of an emergency. To further clarify the rationale behind these code requirements, let's consider some specific examples. Imagine a scenario where a fire breaks out in one of the buildings connected to the shared emergency panel. The fire could damage the feeder conductors that supply power to the emergency panel, effectively cutting off power to all of the connected loads in both buildings. This could have serious consequences, particularly if the fire occurs at night or during a time when the buildings are occupied. Another scenario to consider is a major weather event, such as a hurricane or tornado. These events can cause widespread power outages and can also damage electrical infrastructure. If the buildings are connected to a shared emergency panel, a single weather event could potentially disable the emergency power system for both buildings. In contrast, if each building has its own dedicated emergency panel and generator, the impact of a single event would be limited to the building where the event occurs. The other building would continue to have emergency power, ensuring the continued operation of critical services and equipment. It's also important to note that the National Electrical Code is not the only standard that addresses emergency power systems. Other relevant standards include the National Fire Protection Association, or NFPA, 101 Life Safety Code and the International Building Code, or IBC. These standards provide additional requirements for emergency power systems, including requirements for generator sizing, fuel supply, and maintenance. When designing and installing an emergency power system, it's essential to comply with all applicable codes and standards. This will help to ensure that the system is reliable, safe, and effective in protecting human life and property. In addition to the code requirements, there are also some best practices that should be followed when designing and installing an emergency power system. These best practices include, firstly, conducting a thorough load analysis. Before designing an emergency power system, it's essential to conduct a thorough load analysis to determine the critical loads that need to be powered during a power outage. This analysis should take into account the power requirements of each load, as well as the duration for which the load needs to be powered. Secondly, selecting the appropriate generator size. The generator should be sized to accommodate the critical loads that need to be powered during a power outage. The generator should also have sufficient capacity to handle any future load growth. Thirdly, providing adequate fuel supply. The generator should have an adequate fuel supply to operate for the required duration. The fuel supply should be stored in a safe and secure location. Fourthly, installing the generator in a suitable location. The generator should be installed in a suitable location that is protected from the elements and is easily accessible for maintenance. Fifthly, performing regular maintenance. The emergency power system should be regularly maintained to ensure that it is operating properly. Maintenance should include inspecting the generator, testing the transfer switch, and checking the fuel supply. By following these best practices, it is possible to design and install an emergency power system that is reliable, safe, and effective in protecting human life and property. In conclusion, the practice of connecting loads in separate buildings to a single emergency panel supplied by a backup generator is not permissible under the National Electrical Code for several critical reasons related to fire safety and system reliability. The code mandates that emergency circuits be designed and installed to minimize the possibility of damage by fire and to prevent simultaneous damage from a single event. Sharing an emergency panel between buildings introduces a single point of failure, increasing the risk that a fire or other incident in one building could disable the emergency power system for both. This directly contradicts the fundamental purpose of an emergency power system, which is to provide a reliable and independent source of power for critical loads during outages to protect life and property. Therefore, each building should have its own dedicated emergency panel and backup generator to ensure that essential services remain operational during emergencies, in full compliance with the National Electrical Code and related safety standards. This approach not only meets the legal and regulatory requirements but also enhances the overall safety and resilience of the electrical system. The investment in separate emergency power systems for each building is a crucial step in protecting occupants, preserving assets, and maintaining essential operations during unforeseen events.